Hello students, welcome back. How are you? I hope you're all fine, healthy, wealthy and strong. In today's session, we are going to do some more questions based on area of parallelogram and triangle. Okay, in this chapter, in this session, we are going to prove the converse. We have given some triangles and the area of these triangles are equal to each other. On the basis of this, we are going to prove that these lines are parallel to each other. Okay, so we are going to use the converse of it. Okay, and after that, in the next session, we are going to summarize our complete chapter. Alright, so let's start with today's first question, which is, in figure, AP is parallel to BQ is parallel to CR. So, what is given to us, guys? That this AP, now have a look on AP, this is AP. This AP is given parallel to BQ. So, okay, parallel to BQ, and this BQ is parallel to CR, parallel to CR. Now, we have to prove that the area AQC is equals to area PBR. Now, we have to be very focused about these areas, what these areas are. So, have a look on that. AQC, this area, we need to prove that this area, this complete area is equals to nothing but area PBR, this area. So, first thing that came in our mind is, okay, if they are between the same parallels are having the same base, then the area of these triangles will be the same. Now, these two triangles are having no common base and are definitely not between the same parallels. So, what rule we can apply? Okay, in this case, in such kind of cases, we just try to divide the triangle into 2 or 3 such many triangles, that these triangles that we have divided will be between the same parallels and we will be having same base. Okay, and we'll be applying this area theorem, that the area of T is equals to area of P plus area of Q. Okay, and with that, with the help of that, we are going to prove it. Okay, so we have discussed the method, how we are going to prove it. Okay, now let's start with the proof part. We are having no any construction, given you are having this AP is parallel to BQ is parallel to CR. This you have given. To prove in section, you have to write that area AQC is equals to area PBR. So I'm going to write the proof part only here. So help yourself with that previous part. Okay, now given AP equals to BQ, it's not equals to, parallel to BQ, parallel to CR. I have represented that in yellow lines. Okay, you can see that. Now, if I'm telling you to have this complete triangle, in order to have this complete triangle, can I bifurcate it into this first triangle, ABQ, and the second one, right? So, if I can do that, if I'll be proving this to this, equal this to this, and I'll be proving this equals to the second one, and then I'll be adding these equations, then I can have my result as AQC equals to PBR area. Okay, okay, so now if AP is parallel to BQ, now if AP is parallel to BQ, AP is parallel to BQ, we are having this AQB triangle and PBQ triangle on the same base BQ and between the same parallels AP and BQ. Okay, so the area of these two triangles are what? Equal to each other. Okay, implies that area ABQ will be equals to area PBQ. The first thing, and the reason of it is BQ is common base Okay, and the second thing is AP is parallel to BQ that we have mentioned earlier. So this first thing, you got that. Now the second thing, also BQ is parallel to CR. So now what we are having, that if these two lines are parallel to each other, this BQ is parallel to the CR, in that case we are going to have this triangle, not this triangle, but as per our question, this triangle BCQ, okay, and this triangle BQR, having the same base BQ and between the same parallels BQ and CR. Got that? Okay. Now, this implies that, is this visible to you or not? This implies that area BQC will be equals to area BQR, right? That will be the second thing. Now, the reason of it is, the first thing you're known to it, that BQ is parallel to CR, and the second thing is also BQ is the common base. So area of two triangles having the same base and between the same parallels will be equals to what? Equal in area, okay, to each other. Now, with the first and second, what we are getting? Just add them. Adding 1 and 2 equations. So you are having area ABQ here, this side, plus area BQR, this side. Alright, that will be equals to area PBQ plus area, the next one is BQR. Okay, can I rub that now? Okay, students, now by adding it, what we are going to have, now look at this ABQ, this complete area. Okay, should we rub all things here so that that will be easy to understand in the figure? And draw proper diagram, because diagram is the key for the question. Okay. Now, we are having ABQ and BQR. So, ABQ is this and BQR this. So, is this the same triangle we are having as this ACQ? Mark it, ACQ. So, this is the ACQ. Okay. That means area ACQ is equals to area. Now, what is this area, students? Have a look on it also. PBQ. This is PBQ. Okay, this area is PBQ. Now the second area is BQR. So BQR is this area. Now what we have to prove on the other side is area PBR. Is this the area PBR? PBR. Yes, this is the same area PBR. Okay, so can I write it here? Area PBR. This is what you had to prove. Understood? So, we had proved this thing. In the previous questions, what we have done, we applied that these two lines are parallel to each other. So, these two areas are going to be equal to each other. But in this particular question, there is no direct approach. So, we bifurcated in the two parts and then prove the same. Okay? Done with that? Now, with the next question, some similar kind of question is here. This in figure, area DRC. Okay, so area DRC, this area DRC. This area DRC, okay, and area DPB, DBP. These two areas are equal, show that the both quadrilateral ABCD and DCPR are trapezium. So, in order to prove that these two quadrilateral ABCD and DCPR, these two quadrilateral, should I use different color here? DCPR. These two quadrilaterals are what? Trapezium. In order to prove that trapezium, we need to prove, what are the trapeziums? Trapeziums are having one pair of parallel lines. Okay. So these are not easily, these are easily visible that these two AD and BC are not going to be parallels. AB and DC, maybe, maybe not. DC and RP, maybe, maybe not. So in the previous question, these lines were given parallel to us and we had to prove that these particular areas are equal to each other. Okay, so we are going to try the reverse process of it. We are going to prove that this area, this triangle's area is equals to this triangle's area, and this triangle's area is equals to this triangle's area. With the first two, we can prove that if these two triangles are having the same area, that means they are having the same parallels in between the same base. Okay, similarly, we are going to prove for this. And after adding them, we can just prove that, okay, yes, we are having AB parallel to DC and we are having DC parallel to RP. If we are having AB parallel to DC, that means, yes, ABCD is a trapezium. Similarly, if you are going to prove that DC is parallel to RP, then we are going to prove that, okay, DCPR is a trapezium. So this is our strategy. Now we are going to implement it, okay, in our solution. So we have to prove ABCD and DCPR are trapezium, or what? AB is parallel to DC and DC is parallel to RP. Or you can just simply say that AB is parallel to DC is parallel to RP, right? Okay. Now, we are not having any construction here, so direct proof we are talking about, right? Okay, so we have given that DRC equals to DPC. Okay, area DRC is equals to area DPC first, and area BDP is equals to area ARC. Area ARC. Okay, this area ARC is equals to area BDP, and we are having DRC. DRC, these two areas are equal to each other. Okay, now by second minus 1, what will be we having? By second minus 1, area BDP minus area DRC, that will be equals to area ARC, minus of area DPC. Now, tell me what is area BDP? Area BDP minus of area DRC. D. Here we are having BDP minus of area DRC, minus of area DRC. C. So here some, so we are having DPC here, DPC. Okay, so we are going to flip it, okay, because this is not solving our purpose. We can just have the second equation as, this equation as flipping it like area ARC equals to area ARC with DRC, with DRC we are going to have area ARC. Okay, so in the second one we are just going to have this area ARC here is equals to area BDP, right? Now by second minus 1 we are going to have area ARC minus area DRC will be equals to area BDP minus of area DPC. Understood? Okay. Now, what will that be? Area ARC area ARC is this area minus area DRC, minus area DRC, so this area. Okay, if we are minus this area from that area, that will be ADC. Okay, implies area ADC is equals to area BDP. What is area BDP? BDP, this complete area, and we are going to subtract the area DPC. DPC, this area, we are going to subtract this area from it. Okay, so we are remaining with the BDC. Okay, area BDC. This is equation number 3rd. By equation 1, what is equation 1? DRC. What is equation 1? Area DRC. So this area DRC is going to equal to area DPC. DPC. These two areas are equal to each other, and DC is common base. Right, what I am saying to you, by equation 1, which is saying that these two triangles are having equal area and also having this common base DC, this implies that DC is parallel to RP. First has been proved, right. By equation 3rd, by equation 3rd, which is equals to that area ADC, area ADC is equals to area BDC, area BDC. These two areas are equal to each other. Okay, and if these two triangles area are equals to each other, that means having the same base DC, that means AD had to be parallel to DC. Alright, so okay, and DC is common base, implies that AB parallel to CD. Right, you can conclude it here also, that by that we can prove that these two are parallel, or you can just simply say this implies that ABCD and DCPR are trapezium because AB is parallel to CD and DC is parallel to RP. Okay, so by this you can prove that. Understood? Right. So This is about today's lecture, today's session. In the next lecture, we are going to summarize it, okay? And after that, we are going to start a very new chapter, students. So keep studying, take care, very, very good care of your health. Bye-bye.